Decimal students, this is Aurora with Supercharged Math. We're going to start with a quick review, and then we're going to end today with playing a game, teachers versus students, and we'll see how it goes. All right, so if I were to say, convert this to a decimal, could you do it? I bet you could. Let's go back down to my desk. I would like this number converted to a, oh, did I say converted to a decimal? I meant converted to a fraction. Make this a mixed number fraction. Okay, go ahead. So tell me, what is that in fraction form? Okay. Okay, so it's not 3 over 2. Okay, so if we just say it out loud, that should help. This is 3. This is the whole number 3. 3 and 2 tenths. Yeah? Did you get that? All right, I know, we're waking up. Yay! Okay, let's do another one. Now that we've done one, can you do this one for me? Do this number. Convert to a fraction. Okay, so convert that to a fraction. I'll just give you about 8 seconds. Go for it. Convert that to a fraction. Oh, good. So I've seen some answers. 1 and 5 tenths. And if you also said 1 1/2, you're correct because you reduced the fraction for me. Good. All right, how about this one? What is that one? Yes, the 0 is important. Good question. Okay. So you don't have to write the whole number 0. Yeah, usually we just leave that off. Okay, what would you say about this one? Yep, this one would just be 7 tenths. Right, okay. How about this one? Give this as a fraction and then also draw it. Show me what it actually means in the real world. Okay, what would that one mean? Okay, good. I'm seeing a number of you have got the number. Whole number is 4 and 6 tenths. What does that mean? That means we have 4 whole giant pizza cookies. 1, 2, 3, 4, but not a whole 5th one. Otherwise, that would be a 5. Okay, the divisions on the bottom, that tells us how many make a whole. So 1, 2, 3, 4, 5, and we're going to color in 6 of them. There's 5 and 1 more. So this is 1, 2, 3, 4, and 6 tenths. How are we feeling so far? Let me see a look on your face. How are we doing? Doing okay? Okay, good. Excellent. Now, when we talk about fractions, a lot of times, when we talk about decimals, a lot of times what we're doing is we're taking fraction numbers and making them easier to work with. For example, if I said 3 and a 5th plus 1 1/2, you remember from fractions, yeah, everybody just say yuck, right? This can be a hard one to do. So instead, what we do is we scale up the fractions until the bottom is a 10. 3 and 2 tenths, so we can scale this by multiplying top and bottom by 2 over 2, this one by 5 over 5. So now we have a fraction with a 10 on the bottom, and that turns into a decimal very nicely. Are you seeing this? And this is a lot easier to work with. So can you do this for me? Can you tell me what this equals? How do we add our decimal numbers? Yes, that's right. I would stack it vertically. That would be my first, the first thing I do. Okay, here, let me move it. Okay, so we're going to stack it, and everybody's in their own lane. You're going to make sure the decimal points are lined up. 2 and 5 is 7. Drop the decimal point. 1 and 3 is 4. Did you get that? Good. Oh, yeah, it looks like most of you got that. Excellent. Good. How about this one? 11.2 plus 5.7. I want you to do this one two ways. I want you to do it nice and open and big like this, and then I want you to do it sloppy and tell me if you get the same answer. Can you do that? I want it once neatly and once super sloppy. What do I mean by sloppy? Oh, what a great question. If you don't know, then you actually are a step ahead of everyone else. Let me show you what sloppy means. There's sloppy. You're not quite sure. Nothing's lined up. Actually, that's pretty neat for being sloppy. Here, let me try another one. The numbers all look the same. There. Can you guys do it sloppy? Okay, let's do it neat. 11.2 plus 5.7. If you make a mistake, this is usually why, because the number, you didn't line up the decimal point. Yep, this one I could see 61.7 might be the answer you get, which is ridiculous, right? You can't get 61 by adding 11 and 5. 11 and 5 make 16, not 61. So this is wrong. Okay, 2 and 7 make 9. Drop the decimal point. The 5 goes with this one because they're both in the ones place. There's a 6. Drop the 10s. I have 16.9. Yay. So teachers often have to grade work that looks like this. And you know how hard it is to grade work and you really want to give points to the student, but you can't. All right, you ready for another one? Of course you are. You were born ready. How about this? 13 and 7/10 plus 9 and 9/10. Okay, can you do that one for me? Somebody said they got a sloppy answer of 6.8.2. Oh, I love a sloppy answer with 2 decimal points in it. That's awesome. Okay. 13.7 plus 9.9 goes here. You all are really good at adding whole numbers. So that's pretty much all you're doing here. You're just lining up the decimals so you know which number goes under which one. So the 7 and 9, you just write the 6 here. You do the carry. 1 and 9 makes 10. Plus 3 is 3. There's another carry. Okay, because we have 1 plus 3 plus 9 is 13. Here's the 3. Here's the 1. Is that the right answer? Yes or no? Shake your head. No. My answer's wrong. Don't give me full credit right now. Yeah, forgot the decimal point. Basically, what I said is 13 plus 9 is 236. That's great. That's wrong. But this is right. 13 plus 9, 13 and some change plus 9. This is almost 10. It's about 23.6. Yay! This is a full credit answer. Excellent. All right, can you add 10 to 3 3/10? So add 10 to 3 3/10 and just show me what you get. Just the number 10. Okay, whole number. Yep, whole number 10 to 3 3/10. Okay, should we do it together? Okay, so what did I just say? I said add to 10, 3 3/10. Okay, there's no decimal point here. It's hiding. You can't really see it. You pull it out when you need it. And it's always to the right of the whole number. So this becomes 10 and 3.3. Now, if this is freaking you out, there's like nothing here. Maybe not freaking, but if you're a little concerned, there's nothing here, just put a 0. 0 and 3 is 3. Drop the decimal point. 0 and 3 is 3. And this makes for probably one of the most easiest calculations you had to do all morning. Good. Excellent. Okay, great. So you are now professional decimal adders, which is great. So let's talk about rounding. I want to round to the nearest whole number. Nearest whole number. So if I give you a number about like 4.7, how would we do that? So what you do is you find where here, I'll use an index card. Okay, so you take a look at the whole number, 4, and then you just peek. You say, okay, 0.7, anything that's 5 and up means that this number goes up, and we still throw this away. So we're just peeking here. We take one little peek here, and if it's 5 and up, then we round up. Okay, so 4.7 rounded up gives me 5. Let's do another one, 16.9. Okay, round to the nearest whole number. Okay, so whole number means we should not have anything to the right of the decimal. Okay, we shouldn't have a decimal part of the number. So the whole number is going to be this thing. We're going to peek here. This is above 5. So we're going to round this number up to a 7. So this is rounded up to 17. We still throw this part away, but we're just peeking to see whether this number stays the same or we get to throw it away. I'm sorry, not to get thrown away. This number stays the same or it gets bumped up 1. Okay, let me try another one. How about this? 23 and 6/10 rounded to the nearest whole number. How would you do that? Nearest whole number means my answer will not have a point anything, no decimal point. So this is the number. We're peeking. This is above 6. This is 5 and above. This is 6, which is greater than 5. So this says bump this up to a 4, and you're still getting rid of it. We just peek to see what we do here. So this rounds up to 24. Okay, there's no decimal point if I say round to a whole. Let's try another one. Here's a couple more. 13.3, 2.1, and 4.7. Ready, go. You tell me, rounded to the nearest whole number, there should be no decimal points in your answer. Okay. So this is the number. We're peeking. This is not quite 5. So this stays, but we still throw this away. So this becomes 13. 2.1, we're keeping the whole number, and we peek. Oh, nope, that's not quite 5. We still throw it away. What about this? Okay, so this is the whole number. We peek. Oh, this is above 5. So that means this gets bumped, and we still throw it away. Are you seeing how this goes? So we should have 13, 2, and 5. Did you get at least one of them, or at least know where they come from now? Okay, and depending on, and you ready for the frustrating part? Depending on what you're doing, different disciplines will have different rounding rules. So in mathematics, this is the one we use. If you're in chemistry, you'll look here and say, okay, if this number is even, then we round one way. If it's odd, then we round the other. There's good reasons for it. It's got to do with statistics and probability, but just know that depending on what field you're in, the rounding rules might be different. For us, for just in math, what we're going to do is we're going to do the 5 and above. Somebody's asking, is 0 also included in 5 and above? No, so it's 5 through 9 means you round that number one step to the left, you bump it up 1. If it's 0 to 4, then you do nothing. You just kick off the decimal and just keep it. Okay, let's practice a little more so this makes sense. Okay, so I want you now to round to the nearest tenth. Okay, so rounding to the nearest